Here we would like to find the general solution of the differential equation dq by dt is equal to k times q, where k is just some constant. Now, this is a first order differential equation because the derivative of our unknown function q, the derivative is only a first derivative. So this is a first order differential equation, and in fact it is separable. And the reason it's separable is because I can move everything that has to do with q onto the one side, everything that has to do with t onto the other side. And so let's just go ahead and do that. So this is the original differential equation that we have, and we can just turn that into, by multiplying both sides by dt and dividing everything by q, what we arrive at is 1 over q dq is equal to k dt. Now, of course, I should point out here that this is not a fraction, but in this case it actually kind of behaves like one. So we can go ahead and do this, and this is okay, but in general we can't. So now I'm going to integrate both sides. I have 1 over q dq is equal to the integral of k dt. K is just a constant. The integral of 1 over q dq gives me the natural log of the absolute value of q is equal to the antiderivative of a constant with respect to t is just kt. There is a constant of integration on the left hand side, and there's also a constant of integration on the right hand side, so I'm just going to combine those two constants into one constant and put it on the right hand side. Now what I can do to help isolate this q is I'm going to put this into the exponent of the natural exponential, so this becomes the e to the ln of absolute value of q, and that is equal to e to the kt plus c. Of course, this left hand side becomes not that. This is still e to the kt plus c. The left hand side becomes the absolute value of q, and the right hand side I can actually separate this e to the c away from the k times t because of just exponent laws. And now that I'm in this situation here, I can replace, I can actually do this. I can take away the absolute values if I put a plus and a minus on the front of this, so it's e to the c, e to the kt. And now what I'm going to do is I'm going to rewrite this. So this is just some arbitrary constant. The e to the c has got to be positive, but because we multiply by a plus or a minus, this thing here in the circle is actually going to be an arbitrary constant, which could be positive or negative, and I'm just going to call that a. And so at the end of the day, our solution becomes q is equal to a e to the kt, where a is any real number.